So here is section 11.9. One of the main use of power series is to represent other functions. So what we are trying to do here, so we have some function, any function, let's say f of x. We want to write it as some kind of power series. Okay, so this chapter basically is expanding a simple function into power series. The interval of convergence is then set on which this representation is valid or where the power series converges. So whatever your interval of convergence of your power series will be where this function can be equal to the power series. We can then treat the function as a sort of infinite polynomial. In particular, we will be able to evaluate integral involving some function which don't have elementary antiderivative. Okay, so this is really useful later on in higher mathematics. So let's start with a very simple example which you already know. In the last chapter, we learned that if we have a geometric series 1 plus x squared plus x cubed and so on, that is a geometric series with r is equal to x, that's convergent if absolute value of r, which is absolute value of x, which is less than 1, that can be summed as 1 by 1 minus x using the formula a by 1 minus r, right? Now the same equation, this is true, right? If I can write it reverse, I can say 1 by 1 minus x is equal to 1 plus x squared plus x cubed plus so on. So basically, if I name this function f of x, that is represented as a power series here, and this one converges if absolute value of x is less than 1. Interval of convergence we know is negative 1 to 1. Okay, so to start with, this is a really simple, as we said, we need to learn how to write functions as series. This series can also be written as sigma n from 0 to infinity xn, right? So that is in the summation form. This is n from 0 to infinity x the power n. So in this next few examples, I'm going to use this representation to write some other functions as a power series. Okay, so let's do this example number 1. Example number 1 is a question about power series represented by this function. So we need to write a power series of this function, which is centered at 0. I'll explain in a minute what is centered at 0 means. Also, you have to find radius of convergence. So let's write this function down. This function is x squared by 1 plus 3x. I'm going to manipulate it a little bit so I can work with it. X squared times 1 by 1 plus 3x. Okay, it's the same thing. I'm just writing it differently. That's x squared 1 by. Now this 1, this is plus sign, but I want it to be minus sign. So I want to write it as this. I can't change the sign. It's still positive, but I'm just writing it two negatives, right? 1 minus 3x, right? So let's look ahead one more time what we said. If we have 1 minus x, then that can be written as this function. Now, can you compare 1 by 1 minus x with this? So that means they look quite similar, only that in place of x, what do we have? We have negative 3x. So using that, we can say x squared is outside, but this portion using our given example can be written as sigma n from 0 to infinity. In place of x, what can we write? Negative 3x power n. Okay, let's expand it now. X square is outside, sigma n from 0 to infinity, negative 1 power n, 3 power n, x power n. Although it looks like this whole thing is a very complicated sum, but basically this is, you guys see what it is. This is x square outside when you open it up, this is like sum of the terms, right? So what does sum of the terms means? If we have x square outside, x square will be multiplying with each of the terms inside. So using distributive property, we can say this is sigma n from 0 to infinity. Each term will be multiplied with 2, x the power 2. So we'll have negative 1 the power n times 3 the power n times xn times x square, n from 0 to infinity. When you have multiplied two things with the bases same, then powers add. So negative 1 the power n times 3 the power n times x the power n plus 2. Okay, so we wrote this function as this series. That is your answer. And we started it from here, right? This series is a geometric series. This converges if r here is negative 3x, right? So absolute value of r would be absolute value of negative 3x, which is 3x. If 3x is less than 1, okay? When is 3x less than 1? When absolute value of x is less than 1 by 3, then this series will be convergent. Therefore, we have our function can be written as this series with radius of convergence equal to 1/3, because this is 1/3.